Hello, this is Mr. Stansbury. I'm going to take you through the 2014 Paper 2 problems. All right, so first one, lengths L in centimeters of 100 copper pipes at a local building supplier were measured. The results are given in the table below. Part A is find the mode. Okay, so the mode is the one that happens the most often. Right, so of this one here, the mode, there's frequency of 32, that's 47.5. So that would be our mode, 47.5. And I'm going to put centimeters because that's the label that should go on that, so we'll go with that. Using your graphic display calculator, write down the value of the mean, standard deviation, and median. Okay, so to do that on our graphing calculator, you gotta go into Stat, and we're gonna edit, and we're gonna edit our lists, right? So we're gonna enter in all this data in list 1. The frequency will go in list 2. Okay, so once you have all your data in there, we go back into Stat, and we are going to calculate. And even though there's 2 lists of data, it's still just one variable, right? Because this is a frequency table. So we're going to click on one variable, stats, and then, and I believe the 84s, I think it actually gives you the option of is there like a frequency list? It'll tell you right in here. In the 83s, it doesn't. So what you have to do to show that the first list is our data, and then the second one is our frequency, you have to do parentheses, and then we have to do list 1, comma, list 2. Right? And then if you enter that in, it should give us the correct data. If you don't do that, it's going to end up just thinking that these are your only 5 pieces of data when we obviously have a lot more than 5 pieces of data. Okay, so the mean. So again, since it says write down, it doesn't ask you. It's not asking you to show any calculations. So the mean is our 45.85. Standard deviation is this one here. Remember, it's like the little O with the cape, super O. That's 17.08. So let's go with 17.1. Right, and then the median is going to be down below here. Here's our median at 47.5. Okay. And then it continues on. Next part there is find the interquartile range. So interquartile range is quartile 3 minus quartile 1. So we are going to do 62.5 minus 32.5. And that's going to give us, what, 30 centimeters would be our interquartile range. Okay. Draw a box and whisker diagram for this data on graph paper using a scale of 1 centimeter to represent 5 centimeters. So I've got us a graph here. This should look similar-ish to what you're going to have on your IB test. Okay, so here's your paper, and so they're saying we'll let 1 centimeter represent 5 centimeters, and on your paper, all these dark lines, that's a centimeter. So we want each one of those to be 5 centimeters, so it'd be like 5, 10, 15, 20. If we look in here, 17.5 is the lowest, so we can either start at, like, say 15, but I would actually start, I'm just going to start at 10 down here, and again make sure that you label these down here. So I'm going to go with 10. Let's see, that would make this 20, so we got to go every 2 to make 10, right? So 30, 40, so forth and so on, right? And then be sure to label your axes. So there's really only one here, so we're going to write, this is the length in centimeters, so you can just do that. Okay, and then what we want to do is put all of our 5-number summary in here, right? So our 5-number summary, there's our minimum, quartile 1, median, quartile 3, let's see, and there's our max. So minimum's at 17.5, so here's 17.5, that's where my end of my whisker is going to go, right? And then the quartile 1 is at 32.5. So that's going to be there. I just like to make my 5 dots for that and make a box around all of it. Median 47.5. Right. Quartile 3 at 62.5. And then max at 75.5. 77.5, sorry. Alright, so there's that. Once I get all my dots on there, I know I'm going to make a box around the middle 3 dots, right? I'll do that. So there's our box. This is our median right here. It should go through that line there. And then here's our whiskers. Okay. So that should be enough. If you're worried that people aren't going to be able to tell exactly where your numbers are at, it wouldn't hurt to write them in. This is 17.5, 32.5, 47.5, 62.5, and 77.5. You could write all those in. Okay? Okay, back to business here. Oops. Let's see. Sam estimated the value of the mean of the measured lengths to be 43 centimeters. Find the percentage error of Sam's estimated mean. Okay, so for that we need our percentage error formula. So here is our percentage error formula. Oops. Right here, and that is found on your formula sheet. And it looks different than what our textbook has, but at least it explains what everything is. So here's our percentage error, VA, which is the approximated value, minus VE, the exact value, divided by VE, and it's the absolute value of that, and then multiply that by 100% to find the percent. So the VA is the approximate value, so he estimated the mean to be 43, so we would do 43 minus, let's see, oh sorry, VE is the exact value, right? So our actual calculated mean was 45.85. That's a 5. Divide all that by the exact value, 45.85. Take the absolute value of that, multiply it by 100 to end up with your percent. Okay, so let's do that. So here's the top here, push enter, divide by 45.85, and that gives us that. And then basically multiplying by 100 just means move the decimal over, and it's the absolute value, so we ditch the negative. So the percent error is going to be 6.22. We round to the 3 significant digits, right? Move it over twice. 6.2. Yep, the 5 tells the 1 to go up, so we get 6.22%. So let's go with that. 6.22% for the percentage error of Sam's estimated mean. Okay? Okay, let's move on. Oops, to the next problem. Number 2. Okay, so an office block, ABCPQR. So this is an office block is built in the shape of a triangular prism with its footprint ABC on horizontal ground, and then they give you all the measurements. The vertical height of the office block is 120 meters. So they give you all the measurements that we need. Okay, and then they're going to start asking us some stuff about it. So calculate the size of angle A to C to B. So we go from A to C up to B. So we're trying to figure out what that angle there is, right? So we don't know if any of these are right angles. It doesn't specify at all, so we can't just use our good friend SOHCAHTOA. We're going to have to use some of our other trig formulas. Okay, so we do not have an angle and the side across from it, so we're not going to use law sines. We're going to use the law cosines, and since we're looking for an angle, we want to use the cosine A formula, and these are all on your formula sheet. All right, and then there's our formula there. So we're we're going to now change these letters to fit our formula. So whatever angle we're looking for, we're going to turn that into A. And apparently it's not going to let me write over the top of this. So anyway, this C is now A, and then this side over here is going to be little c. Sorry, little a now. Right? So let me see if there's a way I'm going to write over the top of this thing here. I think I can make this happen. So there we go. So I'm now turning that into A. We can say leave that as B, and we'll make this C just for our formula for now. Okay, so that again makes this side little a, this is little c, and across from B is little b. Okay, so then we'd say cosine A is going to equal B squared, which is 30, plus C squared, which is 50, minus the A, which is 70. These are all squared. And we're going to divide it by 2 times B, which is 30, and C, which is 50. Okay? So we want to stick that into our calculator. I would highly suggest calculating the top and then calculating the bottom and then finding your angle. If you try to do it all at once, it often ends up in disaster. So let's do this. 30 squared plus 50 squared minus 70 squared, and that is negative 1500. And people get nervous when they see negatives in there. That's okay. Oops, especially when we're talking about cosine. That just means, remember, whenever your cosine angle is negative, that just means the angle is more than 90 degrees, and that's more than possible. So find the bottom, which is 2 times 30 times 50, and that gives us 3,000. All right, so now we're just going to, since we're looking for the angle, we got to do second cosine of negative 1500 divide by 3000. Right, and that gives us 120 degrees. So A is 120 degrees. So that's angle ACB. Okay. Calculate the area of the building's footprint, which is the total area of this here. Okay. So since we now know that this angle here is 120 degrees, we can use our area formula to figure that out. And again, we don't have a right triangle in here. We don't know what the altitude is, but if we use our other trig formulas, we don't even have to worry about that. So let's dig that one up. Okay, so here's the area formula, 1/2 AB sine C. So again, these are the ones that they are giving you here. So now we can actually go back to have this being C, and then this can now be A again. But basically, you just got to remember that this is the one angle that you have, and then these are the two sides that are right next to the angle. So it's going to be area equals 1/2 the two sides that are right next to the angle, so 50 and 30. 50 times 30. And then we got sine of the angle that's in between those two sides, which is 120. Okay? And so here's our calculator. We're in degrees mode, so we're okay. And we push enter, and we get the area at 649.519. So let's see, really, since these are all just to the nearest, this one's to 2 digits, we probably should round our answer to 650, but I believe we will be okay if we put area equals 649. Let's see, that would be just fine. 649. Well, we'd have to round it to 650 if we're going to round to the nearest 3 significant digits. So maybe we just ought to do that anyway. So let's do that. So let's round this to 650, and that you're definitely going to want to put your meters squared on here since it's area. Okay. So that's the area of the footprint, and then the volume of the office block is, the formula for volume is just the area of the base times the height, since this is a rectangular, actually it's a triangular prism. So we just multiply the base times the height. So for that one, we're just going to do 650 meters squared times 120 meters, and we'll see what we get. Okay, so we got 650 times 120, and that gives us 78,000. And that's going to be, this is our volume, 78,000. So you got to make sure that you get, look, you got 1 meter here, 2 there, so that's meters cubed. Okay. Just as a quick note, if you left your 649.5 blah 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 in there and multiplied it by 120, you would have ended up with 77,900, like 942.2 blah blah blah. And that is also acceptable, but if you use your rounded number here on this part here, that is also acceptable. Okay? Okay. Moving on to the next parts. To stabilize a structure, a steel beam must be made that runs from point C to point Q. So remember, this is our actual point C here, and this is our actual point A. So we'll move those back now that we're done with that formula. Excuse me. So C to Q is this length right here, right? So we do know, since this is a rectangular prism, we do know that this is going to be a right angle here. So if we redraw that triangle here, we've got C, B, and Q, right? So we've got something that looks like that. There's our right angle. We know that this is 120. We know that this is 50. So to figure this out, we're just going to have to do A squared plus B squared equals C squared, right? So we'll do 50 squared plus 120 squared is going to equal our CQ length. So we'll still just call that C. Right? So put that into our calculator. 50 squared plus 120 squared gives us 16,900. So we got 16,900 equals C squared. So we got to square root both of those to get C. And we end up getting square root of our answer, and we get 130. Officially it's plus or minus, but obviously you can't have a negative distance, so it's 100. It's positive 130. What are these, meters? Okay, so that's the length of CQ. Okay, calculate the angle that CQ makes with BC. So BC and CQ, the place where those two meet is this spot right here, so we want to find that angle. So on this picture here, it's that angle, right? So we know for sure that these two are right, so let's use those. 120 is the opposite, 50 is the adjacent, right? So we will do opposite and adjacent from our dear friend SOHCAHTOA, which SOHCAHTOA, by the way, is not on your formula sheet, at least not anywhere where I saw it. So that's probably one thing you're going to want to memorize going into your test is your SOHCAHTOA. So we have that. So opposite and adjacent is tangent. So we do tangent theta equals the opposite, which is 120 over 50. And on our calculator, if we are looking for an angle, remember we have to do second tangent. So second tangent of 120 divided by 50 gives us 67.38, so we'll call that 67.4. 4 degrees. So that is the angle that CQ makes with BC. Okay? Alright, on to number 3. The Brahma chicken produces eggs with weights in grams that are normally distributed about the mean of 55 grams with a standard deviation of 7 grams. These eggs are classified as small, medium, large, or extra large according to their weight, as shown in the table below. Okay. The standard deviation and your normal distribution, your normal curve, it's a good chance it's going to show up because this is something that they recently added a few years back to the curriculum. So this is definitely something that you're going to want to know how to do. Okay. So let's see what they're going to ask us. Okay, so first part here says, excuse me, sketch a diagram of the distribution of weight of Brahma chicken eggs. On your diagram, show clearly the boundaries for the classification of the eggs. Okay, so we're going to need to draw ourselves basically our normal curve here, right? So normal curve looks something like that. And then the big thing that we're going to need to make sure to have on here is our mean, which is 55. So right dead center here, we got to show that that is 55. Right, and again, you want to make sure that looks like it's right at the top of the right at the top of the curve. I'm just gonna write the mean underneath here just to make sure that it's clearly communicated. You don't have to do that, but and then now I'm going to start putting in the weights here, right? So standard deviation is 7. So you don't actually have to put the 3 standard deviations above and below, but you just kind of want to have a maybe kind of a general idea. So I might just do this. I'm going to say, okay, there's 1, there's 2, there's 3, 1, 2, and 3. So I know that that's going to be say, let's see if it's 7. So 55 plus 7, that's 62. Plus 7 more is 69. Plus 7 more is 76, right? And then I'll subtract 7 from that to get 48. Subtract 7 from that to get 41. Subtract 7 from that to get 34. Okay. So again, this is just for me. They're not going to grade that, but just so I can kind of get a good idea of where these numbers should fall. So small is 53, so that's right next to 55. So I'm going to want to put my actually, let's do this. Let's have this start on the line here. Do this, and then we're going to want to put that that's 53, right? And then the medium is between 53 and 63. So then our next number is going to be at 63, which is just above our next, or just above our first standard deviation. All right. I forgot I've got a trick where I can draw a straight line. So look at that. Look how perfectly nice and straight my line is. So that's going to be 63. And then I need another one up at 73, right? So there's 69, 76. So it's going to be somewhere in here-ish. Okay, so 73. This probably should be a little bit farther over here, but I think you should be pretty good. Okay, but again, you definitely want to put the labels on all your lines to make sure that you get credit for that. So there's our sketch of our diagram. Egg is chosen at random. Find the probability that the egg is medium. So we want to try to figure out what's the probability that it's between 53 and 63. So this is where you need your graphing calculator. So on your calculator, you're going to want to go into, this is the normal distribution, so you want to go into DISTR, short for distribution, so second variables, and these are all your distributions. We want to use the normal CDF, okay? And then some of your calculators, I think the 84s and above, usually will actually walk you through which pieces to put where. So like it'll ask you what's your minimum, excuse me, your maximum, your mean, and then your standard deviation. Okay, if you've got an 83 or before, you actually have to remember what order that goes in. So again, we have to, the first thing we're going to put in is our minimum. So we'll do 53 and separate everything with commas. 53 to 63 is our high. And then our mean was 55, and our let's see, our standard deviation is 7. So we push that. Oops, I messed that up. I think I messed that up. Okay, I redid it with the right numbers. 53 is the low, 63 is the high, 55 is the mean, and 7 is the standard deviation, and we get 0.4859. So that gives us, if we're going to 3 digits, 0.486 for our for the probability that the egg is medium. So 486. Yeah, so we can do that, or you could do 48.6%. Either one is fine. All right, now we'll do the same thing for extra large. So we're going to go back in here. We'll do, let's see, let's clear that out so it doesn't include it. So second distribution, normal, CDF. Our minimum that we want is 73, and now our maximum is going to be anything possible. So I'm just going to put in a number that's ridiculously too high, which is, say, 200. There's no way it's going to get up to 200. So let's put that in there, and then put our comma in there, and then the mean and the standard deviation, so 55 and 7. Okay, and that gives us a pretty small chance, right, which is 0.0050506. So if we're again taking that to 3 significant digits, we do 0.00506. Right, so that's less than 0.5% chance of happening. Okay, let's move on to the next part. All right, so same info. There's a probability of 0.3 or 30% that a randomly chosen egg weighs more than W grams. Find what W is. So what we have to do with this one here to find W, we're looking for that an egg weighs more than W grams, so we are actually looking for the top 30%. So if you're looking at like a line here, here's 0, here's 100. We are actually looking for the top 30. So what the number that we actually want is we want to find where the 70th percentile is. So that's important. Okay, what we have to do to find the top 70% is we have to go back into our distribution again, and whenever you're given percents and you're trying to find an actual number instead of finding the probabilities, you're going to want to use the inverse norm. Okay, so we go into inverse norm, and now the first thing is we're going to enter in what percent do we want to find. So we want to find the top 30, which is 70%, so we're going to put 0.7, so the percent is always as a decimal. And then the last two numbers, just like in the normal CDF, was the last two numbers are the mean and the standard deviation. So we do 55 and 7. All right, and then that gives us, oops, I only put 5 in there. Let's try that again. So second distribution, inverse, normal, so 0.7, and then we want to have 55 is our mean and 7 is our standard deviation. Push enter and we get 58.7 if we round it to 3 significant figures. Okay, so W equals 58.7, and these are all in what, grams? So that means the top 30% of the eggs are going to be way above 58.7 grams. Okay. Next part, probability that a Brahma chicken produces a large egg is 0.121. Frank's Brahma chickens produce 2,000 eggs per month. Calculate an estimate of the number of large size eggs produced by Frank's chickens each month. Okay, so probability it produces a large size egg is 0.121, right? So they've already given us the probability that it's going to be large. So all we have to do is just take our 0.121 and we multiply it by the 2,000 eggs that his chickens produce, because there's again a 12% chance that it's going to be large. So if there's 2,000 eggs, 2,000 times your 12% should give you the estimated number of large size eggs produced by Frank's chickens. So 0.121 times 2,000, and we get 242 eggs, 242 large eggs. Okay, way to go, Frank's chickens. Okay, let's take a look at the next part here. So different graph here says the Brahma chickens produce eggs with weights in grams that are normally distributed about a mean of 55 grams with a standard deviation of 7 grams. The eggs are classified as small, medium, large, or extra large according to their weight as shown in the table below. Okay, so the selling price in dollars of each size is shown in this table. Probability that a Brahma chicken produces a small size egg is 38.8%. Estimate the monthly income earned by selling the 2,000 eggs. Give your answer correct to 2 decimal places. So they're telling us where to round to. Okay. All right. So we know now that this here is the percent of selling. Sorry, the probability of getting a small egg 0.388. Okay. The medium one we figured out from before was 0.486. Right, 0.486. Okay, and then the large one they told us was 0.121. Okay, so then what we have to do is we have to figure out what's the probability that that it's going to be an extra large egg. So again, they gave us this. They gave us this in the previous problem, and this was the very first thing that we calculated. Right, so all 4 of these should add up to 100%. So let's just do 1, and then we'll subtract all 3 of these. 0.388 minus 0.486 and minus 0.121, and that gives us 0.005 is the probability that it's going to be an extra large egg. Okay, and actually, wait, we found that also on an earlier problem, so it's actually 0.00506 if we're going to 3 significant figures. Let's leave that on there. Okay, so let's see. Estimate the monthly income in dollars earned by selling the 2,000 eggs. All right, so basically we got to take the selling price times the probability that it'll happen, right? And then multiply that by 2,000. So we've got 0.3 times 0.388 times 2,000. And then 0.5 times 0.0486 times 2,000. 0.65 times 0.121 times 2,000. And then 0.80 times 0.00506 times 2,000, right? And that'll give us how much we make on each egg, and then we can add those all up to get our total, what we can sell all those eggs for. Okay, so let's calculate that out. Okay, so here's all the calculations done, and then now all we have to do is add these all up, right? 8, 9, 10, 11, 12. Carry that. Okay, and when we do that, we end up adding it all up and we get 884.20. So they'll end up making, excuse me, $884 with their 2,000 eggs. That's pretty good, seems like. Okay, all right. On to number 4.